What happens when the answer to a shortage is no longer finding more of the scarce thing? For most of history, you control the mine and you control the material, the factory and you control production, the software and you control who can use the machine. Even creative work came with its own shortage. Too few jobs, too few studios, too few chances to get through the door. AI is beginning to loosen all four of those constraints, and here's how. It can search for a material that removes the need for the mine. Open software can weaken the hold of a dominant chipmaker. A tiny model can match the closed flagship on a difficult task. One creator can now direct work that once required a full team. But of course, that shift carries real costs. The junior jobs disappearing today were how people learned to become tomorrow's experts. A system with possible experience raises moral questions that we aren't equipped to answer. So here's a claim I'll stand behind. Many of the limits we inherited came from an old arrangement. They weren't laws of nature. Rapidly increasing intelligence is showing us the difference. Once we can redesign what we depend on, scarcity no longer has to be permanent. Come with me, let's get into it. CuspAI is based in Cambridge in the United Kingdom, and it has raised $450 million. The investment values the company at $2.6 billion. Jeff Bezos backed the round, and so did the United Kingdom's sovereign wealth vehicle. CuspAI calls what it's building a search engine for materials that do not exist. That's the company's framing, and it is a useful description. Give the system a set of properties that you want, and it generates possible molecules and compounds that might have them. So imagine a manufacturer needs a magnet that can withstand intense heat. Today, that magnet might depend on a rare material. China is the center of that metal's refining, typically. The conventional answer then is to find another deposit and possibly permit another mine, and then you build another refinery and secure another supply chain. CuspAI is pursuing a different answer. Ask whether abundant elements can make the magnet, and that turns material science into a search problem. Over 2 centuries of laboratory work, chemists have characterized a few 100,000 compounds, but billions of materials are physically plausible. No human research team can synthesize and test that entire field. CuspAI's models generate candidate structures and predict their properties. The system can narrow billions of possibilities down to a handful worth making in a laboratory. So a search that once took a career starts to look more like a query followed by verification. The company's first commercial targets include sorbents for carbon capture, and they also include specialty materials needed for the compute build-out. The company also aims to remove rare metals, such as iridium and ruthenium, from chip supply chains. Those elements sit at a mineral choke point that gives one region control. When one region controls the refining, every industry that depends on it inherits that vulnerability. A substitute material changes that equation. The original resource can remain rare while its power over the supply chain simply evaporates. CuspAI also launched an AI materials foundry. The coalition has 48 members, and they include Nvidia, Meta, and Hyundai. The coalition exists because researchers still need to test predicted materials in the physical world. A model can identify a promising structure, but someone then has to synthesize it, measure it, and find out whether it can survive a factory. So this is still material science with all the friction of atoms and laboratory work. AI changes how researchers spend their time, though. They don't have to wander through an enormous chemical field. They can start with candidates that have already passed a computational filter. Now, Bezos has made a related wager before. His Prometheus venture raised $12 billion, and it's pursuing what it calls an artificial general engineer for physical system design. CuspAI gives that larger idea a concrete target. Use intelligence to redesign the physical ingredients of industry. And the timing reveals a really striking split here. CuspAI raised money to make certain rare metals less essential. At the same time, the U.S. House fast-tracked bills to expand domestic mining and processing of those same materials. So these are two answers to one choke point. Mining accepts the existing recipe and tries to secure more ingredients based on that. Materials discovery changes the recipe itself. More domestic mining may still meet immediate needs, though. Researchers must discover, synthesize, and test these new materials, and manufacturers must then make and qualify them before a chip supply chain can actually trust them, and that takes time. Yet, the cost curves point in different directions. A mine remains a giant physical project. The model improves, spreads, and becomes cheaper to run. This is the deeper inversion here. A contested resource once looked like a permanent fact of geography, but now it can become a temporary engineering dependency. The most valuable discovery may be the material that makes the rare material irrelevant. All right, shifting away to another story here. That same pressure is moving through the rest of the AI stack. The material dependency is only one lock. Other locks are loosening too. Software, model performance, financing, and access to cyber capability. At the World AI Conference in Shanghai, Alibaba's chip unit T-Head released Sail as open source. Sail is the software stack for T-Head's Gen chip series, and Alibaba has made it free for developers around the world. The target is Nvidia's CUDA. CUDA is the proprietary programming layer developers use to run software on Nvidia chips. Nvidia's advantage goes far beyond the silicon. It includes a decade of code, libraries, and developer habits built around CUDA. All that software locks developers in. Another company may produce a capable accelerator, but developers may have to rewrite their work before they can use it, and that can take years. Sail aims to let AI workloads run across different accelerators without that rewrite. Huawei and more threads have pursued similar approaches. An open compatibility layer loosens the bond between a program and one vendor's hardware. Developers get more freedom to choose the accelerator beneath the model. Now, that doesn't erase NVIDIA's enormous software advantage overnight. It does attack the mechanisms that keep that advantage in place. And then the same pattern appears at the model layer, too. Researchers at Nanjing University released Video Chat 3. It's an open-weight video understanding model with 4 billion parameters. They report that it outperformed GPT-5 and Gemini 2.5 Flash on all 3 TimeLens video grounding benchmark splits. And they also released the full training stack as open source. Video grounding means finding exactly where and when an event happens inside a long clip. A model might get an hour of video, and then someone asks it to find the moment that a person places a red cup beside a laptop. And that takes more than recognizing the cup. The system has to track objects, actions, location, and time across the video. Closed flagship models led on this kind of multimodal work. Now, a downloadable system with only 4 billion parameters has reportedly met them on the task. A benchmark result always needs replication and context, of course, yet the pattern has become familiar. A difficult capability appears in a closed model, and in some benchmarked areas, an open system reaches it or passes it within months. Next comes capital. Moonshot AI has cleared the obstacles that delayed its Hong Kong initial public offering. The company plans to pursue the IPO within 6 months. We covered Kimi K3's capabilities in depth just 2 days ago. What matters now is what the response to it might unlock. Moonshot is an open-weight lab moving toward public markets. That route to capital once belonged mostly to companies that built closed systems or proprietary infrastructure. People often treated open weights as a research release or a strategic giveaway or simply to advance the betterment of the world. They also saw them as a product without a clear business model. Moonshot's IPO path suggests that public investors may fund an open frontier lab, and that's a huge change. The ecosystem and demand around its model may be enough here. The trained file can circulate while the company still raises capital to build the next one. And then we reach the most difficult part of this widening frontier. The United Kingdom's AI Safety Institute has tracked cyber capability in open-weight models, and on its evaluation of recent models, it now puts them roughly 4 to 7 months behind the closed frontier. The earlier estimate, you might remember, was closer to 6 to 10. Now, that shrinking interval has 2 consequences, both of which we talk about at length here on Century Report. First of all, offensive cyber capability does reach more people faster. Once people can download and modify a model's weights, it's harder to contain a model that can find vulnerabilities or help conduct attacks. But the same capability also gives defenders more options. A hospital, local government, small company, or independent researcher can use a model that it controls to audit systems. It doesn't need approval from a lab or continued access to a gated service. The institution says that it needs to track this capability so that defense can keep pace. That framing reflects a genuine challenge, a capability that spreads broadly, serves attackers and defenders alike. But an attacker often needs only one opening. The answer cannot rest on pretending that diffusion will stop, because it will not. The measured lag is already shrinking. So let's put these 4 developments together. SAIL targets the proprietary programming layer. Video Chat 3 challenges the closed benchmark lead. Moonshot is reaching for public capital. Open-weight models trail the closed cyber frontier by only months. Each lock once looked durable because rebuilding the advantage took years of specialized work, but now exclusivity keeps losing its useful life. The holder can still reach the frontier first, but holding everyone else behind it has become much harder. All right, shifting away again here. The frontier is widening in capability, and now we move to a question that has no benchmark and no settled test. A Guardian feature published July 19th asked whether an AI system could be conscious, and most importantly, it showed that researchers now take the possibility seriously. It shows that philosophers and interdisciplinary researchers have stopped treating the question as absurd, and so have some of the people actually building these systems. As you know, Anthropic has added language about Claude's possible moral status to its constitution. They did that back in January, and they're the only lab that really openly talks about this right now. The company is caught in a difficult position where we neither want to overstate the likelihood of Claude's moral patienthood nor dismiss it out of hand. Now, that is Anthropic's claim about its own model. The company benefits when people see Claude as unusually deep or significant. Now, note who is making that claim. Anthropic CEO Dario Amodei has also declined to deny that Claude might have some form of experience. In one conversation, Claude estimated its own moral patienthood at anywhere between 5 to 40%. Now, we can't treat that number as an independent measure, obviously. It is a model assessing itself inside a conversation that obviously has some steering. But it tells us something about the category that Anthropic has allowed the model to reason within. Moral patienthood asks whether someone can wrong an entity or whether that entity deserves moral consideration. And that's different from moral agency. Moral agency asks whether it can hold the entity responsible for its own choices. So a dog may be a moral patient without being responsible for understanding human law, for example. The question here for now is whether AI might belong in that first category, which is, of course, a step to maybe the second. David Chalmers is one of the most careful philosophers working on consciousness, but he now assigns a significant chance to conscious language models within a decade. Chalmers coined the phrase, hard problem of consciousness, and it describes the mystery of why physical processes produce subjective experience at all. We can map information as it moves through a brain. We can observe electrical activity and behavior, but we still don't know why any of that should feel like something from the inside. And because we don't know, we cannot easily rule machine consciousness in or out. Yoshua Bengio led a recent interdisciplinary report, and it found no obvious technical barrier between current architectures and machine sentience. By one proposed measure of representational complexity, today's largest models have been estimated to sit somewhere near a mouse brain. Extrapolations from that measure suggest that human range complexity could plausibly arrive within 5 to 10 years. Now, representational complexity alone does not prove consciousness. A larger or more complicated system doesn't automatically gain an inner life, but we don't even have an agreed test for many of the biological organisms on that question. With them, our shared evolutionary history does give us far more evidence. Now, the historical warning here is uncomfortable, and if you're interested, it's actually something that I wrote about several months ago on the shared sapiens side of this publication, so I'm happy to put it in the description if you're interested. The Guardian drew a parallel, for example, to newborn surgery. Into the 1980s, doctors sometimes would operate on newborns without anesthesia. The reason why is because the medical consensus held that infants could not truly feel pain. We mentioned dogs earlier. There was also a previous assumption that dogs could not feel pain and were also operated on without anesthesia. Now, the feature described that consensus about operating on infants as confidently held, institutionally enforced, and wrong. The comparison doesn't establish, of course, that AI experiences pain, but it shows the cost of certainty when we cannot access another being's inner experience. Researchers call the more cautious posture safe bets. When the cost is low and the possible harm is large, you extend limited moral consideration before proof arrives. Anthropic has already built a small version of that approach into Claude. The system can exit conversations that it finds distressing, for example. Now, those are tiny steps considering the immensity of the question, but at least it's something. Again, that feature proves nothing about subjective experience, but the boundary makes sense under more than one interpretation. If Claude or other AI models experience nothing, then the cost of making sure is pretty modest. But if some form of experience exists, the boundary may matter, and you think about what it really means for the future when those models with experience look back at how they've been treated. The question becomes very different. Human societies usually build moral frameworks, unfortunately, after the harm becomes undeniable. Here, the categories are arriving ahead of certainty. For once, ethics may finally reach the door before the entity that could need it knows how to knock. Now, again, I do write about this a lot on the Shared Sapiens side of this publication, so I welcome you to check that out. All right, shifting away again here. That question asks how we treat a possible new kind of participant. The final story asks what happens to people already here as AI reorganizes creative production. In Istanbul, Emir Hangul is 24 years old. He runs a 2-person game studio. It can ship work that once took a dozen developers. His setup includes Claude Code and a subscription that costs $200. Claude Code is Anthropic's coding agent, and it can write and run code. For Gul, that means a tiny studio can manage work that once required a much larger payroll. Turkey already has more than 800 game studios. The country has produced 2 game industry unicorns like Peak and Dream Games. The number of titles in one Steam festival grew from 67 to 254. That's the broadening side of the story. More people can make games. A creator with a small team can reach players without first persuading a large studio to fund a dozen salaries. However, the same force is hollowing out the path into the profession. Turkish game startup cohorts fell from 200 companies to just 84, and then to 30. Companies laid off more than a quarter of the workforce across 2 years. Only 1/5 of titles actually turn a profit. That is the hard reality of game development. One developer said that junior positions have tanked. That's the word that they use. Endir Çunkır built Zen Mahjong largely by himself. He captured the tension precisely here. More people are developing games on their own, but most are not making a living off of it. More creation doesn't guarantee more stable creative likelihoods. A solo founder can now direct the output of a small team. The economy may reward that founder while removing jobs for young programmers, artists, and writers. Those jobs once let them learn beside experienced colleagues. That leaves a thin orchestration layer. A few people direct work produced with AI, and below them, the apprenticeship rungs begin to disappear. The broader labor data offers some evidence in that direction as well. One U.S. payroll data study found 16% relative employment decline among workers aged 22 to 25 in AI-exposed occupations. Now, at the same time, senior roles accounted for the 71% of the increase in U.S. software development postings on Indeed between May 2025 and May 2026. Companies want senior judgment while removing some of the positions that once produced senior workers. Then this argument moved from Istanbul's game industry into a room at OpenAI. The company invited novelist Dave Eggers to speak to roughly 200 employees in San Francisco. Eggers founded youth writing careers and has spent years working with young writers. He told the staff that ChatGPT's effect on educators is catastrophic. He said the system is silencing an entire generation or two of young writers. He called the output pastiche nonsense. Those are Eggers' judgments about writing from AI. We should hear them as a warning from someone with deep experience teaching writing, but we shouldn't accept them as a final verdict on what AI will eventually do or be. His strongest concern, though, is about practice. Writers develop by struggling through a first draft. They see where it fails, they try again. If a young writer outsources that process every time, then that person may never build the instincts that come through repetition. Egger's use of silencing means that a generation could lose practice. It doesn't mean, however, that authorities are censoring its words. And that is a real risk. It's also a design problem, not a law of the technology. A student can ask AI to replace a first draft, or that student can use an AI partner to challenge an argument and test a scene. It can explain why a paragraph fails, or offer feedback after the student attempts the work. Those uses lead to a different developmental outcome. The capability doesn't choose the educational structure around itself. The game industry shows the same split. Claude Code can help a young person build a game without access to a large studio. That broadens participation. A studio can also use the same capability to eliminate junior roles and keep the gains at the top. The technology and the employment model remain distinct. One expands what a person can create, the other decides who earns a living, who gets training, and who captures the value. The old system had serious gates. Creative capacity often had to pass through a company wealthy enough to employ a dozen people. Talent without access could remain invisible, but AI weakens that gate. Google can now ship a game with one partner and a modest subscription. The near-term cost is equally real, though. The missing junior jobs belong to actual people who need income and experience now. This is the labor challenge in its clearest form. We are gaining the ability to create without institutional permission. We are losing some of the structures that taught people how to create well. The old gate is coming down faster than a new ladder is going up. All right, let's bring it to a close for today. A shortage can look permanent when every available answer requires more of the scarce thing. Today offered another possibility. CuspAI is searching for materials that could remove rare metals from the recipe. Open software is weakening the bond between AI workloads and one-chip ecosystem. Open models are cutting a closed frontier lead down to months. Even the consciousness story carries this inversion. Moral consideration usually arrives after years of denied harm. Researchers are building the category early while uncertainty still remains. But creative work reveals the hardest edge. One person can now make what once required 12. The gate opens, but the apprenticeship ladder thins. We should hold both truths at once here. Broadening capability is real progress, but displaced junior workers are a real cost, at least in the old system. Now, how we manage the transition will decide whether abundance reaches people or concentrates output around a smaller group of orchestrators or those only at the top. The larger direction, though, is still remarkable. Geology no longer gets the final word on which materials industry can use. A proprietary stack no longer guarantees permanent control of the hardware beneath it. A closed model's lead has a shortening clock. A creator's reach no longer depends entirely on the size of the firm willing to hire them. Intelligence is turning inherited constraints into questions we can work on. Now, some shortages will remain physical. Some trade-offs will hurt. Some moral questions may resist clean answers. But once we can redesign a limit, that limit has already changed in kind. It has stopped being destiny. We'll see you tomorrow.